So now that we have fitted a function to our time series, we can actually start using that to predict some values. We can see that our time series presents some data gaps here, maybe due to cloud cover or something else. So with that fitted values, we can actually kind of sort of created artificial data as well to start filling some of those gaps. And that's what we do here in this other and last checkpoint. The code to this one is actually a little bit more complicated than we are seeing. The current code is already complicated, and then this one to actually sort of like we're actually forecasting the data, it gets really complicated. So in the chapter, we are not describing all of the details about the code, but this is a nice example to for you to actually forecast and fill some of the data gaps that you have in the time series. So it's creating a function here to fill the values, and how it works. It takes a look at previous and future images, so pixel values. So you use here, because we're working with Landsat 16 days apart, and then if that pixel is masked, it sort of creates a dummy image, just a placeholder, and then later on it actually sort of like forecasts and predicts a value for that specific gap for that dummy image. And it feels that it completes that value, it creates that artificial value using the function, the fitted function, the regression function that was calculated. That way, if I run this code, when we chart a time series at that same specific point of interest, let me just run again because the one was printed faster than the one at the bottom. But we can see that, for places here where we had missing data, you can actually sort of fill in these data gaps by using that the model, the fitted model. And this is important, specifically for like crops, agriculture applications. And that's it. That's the end of the chapter. The really complicated is just the beginning. Then it's just short code blocks.